Okay, so really quickly today, we're not going to spend a lot of time on this because this is all review. We're going to review exponents, the properties of exponents, and scientific notation. Okay, those are really the things we talked about last week. That's everything we've done in this unit so far. So let's start with exponents. Okay, when we've talked about exponents, now you guys are going to write this on the purple sheet that I just gave you. Right? Everybody should have a pencil in their hand. You have a purple sheet in front of you. We've talked about positive exponents and we've talked about negative exponents. Okay? For positive exponents, I'm just going to put example like 7 to the second power. What does that mean? Luke.
7 times
7
7.
times 7. Which is 49. Okay? So we know when it's a positive exponent, you just multiply the number by itself that many times. If it was 5 to the third power, that would mean what? Yep, 5 times 5 times 5, which is 125. Okay? We feel okay with that? Okay. If we're talking about negative exponents, if it was 7 to the negative second power, what happens when we have a negative exponent? Turns it into a fraction. I'm just going to put becomes a fraction. So this is 1 over 7 to the second power, which is 149. Okay. What if it was 3 to the negative second power? What would that equal? 1/9, right? Okay, because it's 1 over 3 to the second power, which is 1/9. Coming back to us, remembering these things? Okay, or it's a really good idea that we're going over this because we need to remember it. Okay, so write that down and then flip the page over. Okay, then we talked about properties of exponents. Okay, and we had 3 properties. Do you remember that? Anybody remember what we talked about? Okay, properties of exponents. We had, the first one was product
I don't remember.
of powers. Then it was quotient of powers. And then it was a power to a power. So we had 3 properties we talked about. Okay, I'll give you a second to write that down. And then we'll put an example of each one. Last week, Tuesday. Okay. For product of powers. Okay, that was problems that looked like this. 7 to the third power times 7 to the fourth power. And our goal was to write them as 1 power. So when it was 7 to the third power times 7 to the fourth power, add. So it'd be 7 to the 7th power. Because you add the exponents. Now you remember this? It's coming back to you. Okay. Quotient of powers was when it was dividing. So we might have 4 to the third power divided by 4 to the 7th power. And what do we do with the exponents this time? You minus them. So this would be 4 to the negative 4th power. Somebody remind me why it's negative this time? So remember, you're always subtracting the top one minus the bottom one. So 3 minus 7 ends up -4. You're taking away more than you have. So far, so good? And then the last one was a power to a power. So that looked like this. If we had 8 to the 4th power to the 5th power. What did we do with the exponents this time? Multiply. So this is 8 to the 20th power. You multiply the exponents. Coming back to it. Okay. Trying to get everything in one spot so hopefully you remember it. Okay. The last thing we talked about last week was scientific notation. Okay. Scientific notation, remember, was a way to write really, really big numbers in a more manageable form. Okay, so we could get rid of all the zeros. We didn't want all the zeros. So when we write scientific notation, we were writing in this form where we have a base number times 10 to some power. Tell me about this base number. What did we learn about this base number? See? Has to be smaller than 10. So the base number is greater than or equal to 1. But less than 10. Okay, and then we also have an exponent. And this exponent, we had to count the number of places the decimal moved. Okay, so if I did this example and said I want to write this number in scientific notation. 13 billion in scientific notation. What would we write? So it'd be 1.3 times 10 to what power? 10. It'd be 3, 6, 9, 10. So 1.3 times 10 to the 10th power. You okay with that? What if the problem started like this? 0.000714. What would that be in scientific notation? 7.14, and then what? $7.14 times 10 to what power? Careful, she's really close. The -4th power. So remember, if we're moving it here, yes, it moved 4 places, but because we started as a decimal, our exponent's negative. When we start as a big long number, our exponent's positive. Okay, coming back to you, remembering all of that? Okay, that's everything we've covered so far in this unit.